And we're back. It is the return of the math. This is a play on words from an old song that you probably never heard. We're going to be doing the 2003 AMC 10, we is the royal we, it's us, right? The 2003 AMC 10A Problem 25 and the Relative Problem 18, un momento. But first, announcements. The move is complete, kind of. For those of you who have been following my channel, there was an emergency move from where I lived in California to a new state, not by my choice, and it ate up massive amounts of time. There was 1 week, for instance, where I'm averaging 3-4 hours of sleep a night. I'm pulling 21-hour days of non-stop action, movement, everything. Moment after moment, there is always constant. There's not even 2 minutes of break. You just have to be doing something. Even when you're driving, you have phone calls you have to make while you're driving to make the connections that you need and all that kind of stuff. The good news is the majority of that stress is behind me. Last Sunday was the first day that I wasn't working more than 8 hours and or moving all of my things as quick as I could to a new location in about 3 months. So I had no breaks, no days off for about that whole time. And so it's nice. I got a day off finally, and things are starting to settle in. All my stuff is still in boxes. This is the new room that I'll be filming in, actually. The lighting's a little bad over here. In fact, I noticed on the background that it's a little grainy in the video. I kind of did some research, and it says that has to do with exposure. You need brighter lights. I've got the brightest possible light up here that I can get, and it does a decent job. But I can't really add modified lights. If I put lights, like standing film lights, one of the problems with the whiteboard is that it reflects off of it and then you can't read the writing. So I've got to figure out how to do that, maybe just film in the daytime, but we live with what we live with. And so, yeah, if I can't figure it out, they said that you can increase the exposure, but it will lower the frame rate, which means you'll get some other weird glitch stuff in the video that's not as good of the frame rate quality. Like in my older videos where I see like my lips move, but they don't quite match the sound coming out. That's a problem with frame rate, FPS. So it's kind of a trade-off. And whatever it is, we'll work with it because this is my new digs. Now, summer classes, they are in full swing. I'm probably starting a new class on July 23rd for Intro to Geo. Not down here, Introduction to Geometry. The textbook we'll be using is the similarly named textbook from AOPS. And that class is on, I'm thinking Saturdays from 5 to 7 p.m. Will we finish it by the November test? I don't know. That's assuming that the test is in November. As of today, the dates are not yet released yet. I don't really care to speculate whether it is or it isn't. It doesn't really matter. It'll be when they announce it, and that's fine. It's going to happen sometime in the school year. As far as exactly when and all that, when they decide to reveal that information, they will. I don't care to discuss the dates exactly. I'm going to assume as of now that it's probably in November. So the other book that I might do again is Intro to Combinatorics, or class rather, using the Intro to Counting and Probability book from AOPS. If you're interested in either of these, let me know by email. You can find my email on my channel page. The current classes, I do have a Saturday AMC Fundamentals course. This covers the most important topics that you will see on the AMC. It's broad coverage, not massive depth, but you're going to get a good look at some great problems that will teach you the major themed mechanics that you will find on the test. That textbook is volume 1. It's on Saturdays from 11 a.m. to 12:30 p.m. We are in about chapter 6. This has been ongoing now since the start of summer, maybe chapter 5, 4 or 5, maybe right around there, somewhere in that range. Anyhow, it's still pretty early in the books. It's got 29 chapters. The other two classes you might be interested in are the past test review. Those classes are basically a lot like what I teach on the board. I'm going to go through the questions. We go year by year, all the way from the year 2000 until the present day tests, and I go through as many questions as I can in 1 hour time, and we do 2 tests a week. So each test, 1 hour per test. So 2-hour class. It goes from 3 to 5 p.m. on Wednesdays. This is Wednesdays currently. And the AMC 12 version of the same class is currently on the 2007 test, and it goes from 5 to 7 p.m. These times will change probably once fall hits, the summer's over. Some students on the West Coast don't get out of school until like 3 o'clock, and so it's hard for them to start a class at 3. So I'll probably either move it to 4 to 6 or 3:30 to 5:30, depending on who's attending the class at that time and what they can do. So those classes are going on right now. If you're interested, send me an email. You can check out the class at no cost and see if you like it. So email, comment, responses. Do you send me an email and I don't respond for a week, something? Listen, understand, in the summer times, I do work in session teaching about 60 to 70 hours a week. That's not even counting my client responses, communications with some people that I contract with, other life responsibilities and all of that kind of stuff. So sometimes I intend to respond, but I'm just exhausted. I don't feel that I can give you a good response. I mean, even today I put in a 12-hour shift, teaching 12 hours. And I'm not complaining. It's great. I'm grateful, actually, that I get to do that. Does it make it easy on my time, though? It doesn't. And so just please understand, if you don't get a response back from me, it is never personal. I'm never ignoring it. Maybe it fell through the cracks. I honestly apologize. I try to deliver the best that I can. If you left a comment on my channel in recent months and I haven't gotten back to it, sorry, there's been emergency things going on. Like I said, the move was unplanned. And there's also a lot of things I'm not telling you about that, like I said, go on in my personal life that it's my stuff to deal with. And so it's significant issues though, not a small thing that I've had to deal with in the last year. It's been a pretty traumatic year. So thank you for your patience and all of that. The future newsletter from my website, if you signed up for that sometime in the last year, I had good intentions. I haven't had the time to develop it. At some point, I may or may not take on an employee or a volunteer who helps me to organize some kind of monthly newsletter to send out, or maybe a quarterly newsletter to update people on the ongoings of events in the world of math as far as I'm aware. This has been something I really want to do, but just the available hours in the day, there's only 24 on planet Earth, and I don't always have time to get to it. Besides that, maybe you're a parent and you'd like to help me organize a future newsletter. Hey, or I don't know, anything like that. I don't know how that would work. I'm still trying to get time to figure it out, but when time permits, we'll get to that. Expectations for film schedule going forward. All right, so we're moved. I'm still not really unpacked. I actually just got my dryer. No more laundromat. That's a grateful thing. Film schedule, I don't know. In the early days of this channel, I was filming really consistently because I was just dedicated to it at that time. And I still am wanting to film all the time, but there's a lot of life responsibilities. You have family obligations. I have obligations to my pets, to take care of them, to take them to vet appointments, to myself, to stay in good health, to go to my doctor's appointments and dentists and things like that, and car repairs. And there's a whole bunch of adulting that requires a lot of your time, not to mention having some semblance of a social life, working out, eating right, that kind of stuff that you need to do. And so I don't know that I can commit to anything. This is not a promise, but I'm thinking maybe once every couple of weeks going forward would be my goal. If I only get to once a month, then it's once a month. The good news is we are finally set up. I got the whiteboard set up. For a long time, actually, it was just sitting against the wall because I don't know anyone in my new city who could help me hang the whiteboard. It just sat there and I can't reach over there to get it over there to screw it in. And so I finally got that done. And when I got a few other things, a friend came over to help. Contest sponsorships. Some of you have emailed me about your contests. I love it. Please keep trying to grow the math community, trying to help other people, to inspire others to engage in competition math or even non-competition math. Just grow interest in it in general. If that's what you love, share your love with them. There's a famous quote, what the world needs is people who have come alive. No, I forget what it is. Hold on. Don't ask yourself what the world needs. No. I can't remember. But anyways, I can remember the quote some other time. I'll come back and get you with that one. I'll put it in the description. Don't ask yourself what the world needs. Ask yourself what makes you come alive. And then go do that. Because what the world needs is people who have come alive. and I forget the exact quote. Is it Edmund Burke? Maybe it wasn't him. Somebody said that. It's a pretty good quote. I liked it a lot. I might have butchered it slightly or changed the wording. It's a paraphrase. I don't know. It's pretty close to that though. If you love math, help others to see your love and passion for math in your contests, in your communities, in your school, in the math clubs, and the things that you're doing. As far as me sponsoring your contest, I would really like to. Currently, this is on hold with a few exceptions. Some people asked before my emergency process began, and some people I know personally and have developed a personal rapport with. And for those individuals who I have a lot of respect for, yeah, I'm gonna look out for those people and take care of them as best I can. And I'd love to help you out as well, but for temporary until about the fall, maybe around November test, this is kind of on hold as far as my sponsorships go. That's because I need to recuperate my losses from a horribly expensive moving process and just available time at the moment. But that doesn't mean you can't reach out in the fall or after starting again to continue to have sponsorships for contests. Don't think I don't want to. It's just I'm only one person and I only have so many things that I can accomplish in a day. So with all of that being said, let's get started on this problem. We'll be right back. And so here we are. Let's get started on the 2003 AMC 10A problem 25. It was also the 12A problem 18. I came across this question recently when I was doing one of my classes, and I really like it. I've done it a number of times actually, but it's just a very well designed question. You're kind of blindly fumbling, and if you happen to kind of notice like a little thread, I call it, it's like the problem is like a woven structure, and if you just grab the right thread and you pull on it, you'll be able to see what's going on behind the scenes. But you kind of have to be inquisitive, just be curious, and you have to think, what if I made it look like this? Well, let's see what that looks like. Let n be a 5-digit number, and let q and r be the quotient and remainder respectively. Respectively just means in the same order. So q is the quotient, r is the remainder, when n is divided by 100. A pause there. There's a couple avenues that we could take here as far as our approach goes. One approach would be, let's say that it gave us a 2-digit number. For a 2-digit number, I like to use capital AB, and I like to use the expanded form 10A plus B, and you work within that kind of framework. We could do that here, but it's a 5-digit number. And, 10,000A plus 1,000B plus 100C plus 10D plus E is a little unwieldy. So we kind of don't want to use that. But we can come back to it. If we really have to, if we can't find any other path, we're going to put that plan on the back burner. But first, we're going to explore a separate plan. And it has to do with quotient and remainder. And actually, the way that I remember what I'm going to do right now is I remember it off the polynomial version of the division algorithm. What is that, you might ask? Let's get a look at it. It's going to be, I call it has two versions is what I call it. It's really the same thing, just looks different, okay? The first version, the first level that you should understand for it is that if you have a polynomial, just a polynomial function of x, and you have a divisor as a function of x, and you execute this, it will be equal to the quotient when you divide by the divisor as a function of x plus the remainder as a function of x over the divisor. Now this is the first level of understanding. It's the one that I actually think of easier typically for some reason. I always think of this one first, and then I manipulate it to get the second version of what we want, which is going to be if I was to simply take this and multiply it by the divisor. So you're going to get q of x, the quotient, times the divisor plus the remainder. Understand when we say remainder as a function of x, we don't necessarily mean there's always going to be an x in it, but there could be for certain situations. Now, this is not what we have because we don't have a polynomial. But let's look at what the division algorithm looks like if we just take this and adapt it to our situation. Instead of p of x, we're going to have n. And we're going to say n divided by the divisor, but it's not a function of x. They told us what it was divided by. They said it's divided by 100. So n over 100 is going to equal the quotient plus the remainder over 100. And I never know at the start which of these two versions is going to be more powerful. I'm a big fan of not having a bunch of extra memories for different formulas in general. There's a couple times where I break my own rules, but hey, we're allowed to do that, right? And anyhow, so I don't know if I want to look like this or like this, but I do know that even though this is for polynomials, it's the exact same conceptual idea as this. And so when you think of it that way, then you only need one memory to recall both formulas. So now what? Let's go back and read and see if we can figure out if this is the better plan or if it's better to look like that. So for how many values of n, that's this one, is q plus r divisible by 11? What? Like this divisible by 11? How many values of n this is that plus that without the 100 divisible by 11? Well, that doesn't seem very simple. It's kind of overwhelming, which is probably why it was problem 25 back in the day. Also, quick note, many of you remark about how easy tests were back then, but you have to remember there were not that many resources back then. Many of the AOPS books were yet to be written, for example, and there wasn't a lot of resources that you had. There were teachers maybe that might have something, a book, maybe they went to a conference and they had some material they had come home with from their conference they went to in the summertime. But if you didn't have access to those teachers, then you really didn't have a lot of access to stuff. The internet, didn't really have a whole lot. I forget if Amazon was even around at that time, but if it was, it wasn't that old yet. And so it wasn't really, these kinds of ideas which you might look at in the modern era and go, wow, that's so easy, how easy they had it back then. But you don't realize how much easier you have access to resources today that they didn't have. So just keep that in mind when we're going through these older questions. And there's still a lot to be gained from this. There's still key concepts. This is a small notebook concept. If you know what I'm talking about, it's the notebook of formulas. If you don't know what I'm talking about, look up my explanation for why I recommend a small notebook for keeping track of all of your major ideas. And this is a huge idea within the contest. So, what are we going to do here? Well, if this doesn't look like something we know what to do, just try changing it. In general, when you don't know what to do, if there's something that you can do, well, you should do it. Is it going to work? That's the wrong question. If you don't know what else to do, then you better try something. It's about survival, okay? So just whatever, I don't know, I'm confused, I'm panicking, there's a time, there's clock ticking, right? Just make it look different. Change it in some way. So if I was to multiply this to the second version, I would get n equals 100q plus r, because the 100 goes away here and just attaches here. Now, I don't know about you, but in general, I kind of don't like fractions as much. That looks a lot nicer, okay? So I'm probably going to think more at this one. I'm going to focus my thoughts on this and less on this one. If I try to look at this and I still can't come up with anything, I might move back to this. I'm talking about the mental strategy I'm using when I'm taking this on the test, okay? So now, if we're looking at this, and this is the thread, okay? You up here, you look at it for how many values of n is q plus r. And if you're looking right here, I don't know how to make it any more obvious, but if you pause the video and think about it, you should see that here. And you go, well, no, there's 100 q plus r, but I only want q plus r. If only we knew what multiplication was. What is multiplication? Maybe we should ask ourselves that. It's repeated addition. So for example, if I have q plus q plus q, that's 3q. And if I want to make it go backwards, back to where it was here, I can go back the other way. I could even go 2q plus q if I wanted to. And so yeah, that's kind of the stuff we're thinking of. So then if I can do this back to here, then why can't I do that here? I can. And if I do that, we're going to get n equals, it's going to be 99q. How many q's should we split off? Probably enough to make it look like that, because that's what we want to think about, right? Plus q plus r. Okay, well now I've got the expression I want to think about. If they give you something and they say, do something with this, then try to make sure you can see that, maybe, in the problem. And we can see it right here. So now let's reread the question. For how many values of n is that expression right here in the box divisible by 11? And now we have to kind of go, well, I still don't know if we're that much closer, but there's something about 99. Man, if only it would hit me. I probably has nothing. Oh, wait a minute. It's divisible by 11. That's right. And so if we're looking at the 99 and we say, well, if that's divisible by 11, and they're asking me for how many values of n is this, let's just pretend. What if this number was divisible by 11? Let's say whatever, it's 22 or something. Who knows? Just some number, okay? Q plus R. If that's divisible by 11 and that's divisible by 11, what does that tell you about n? That it's divisible by 11. That's right. So if you have two numbers that are divisible by 11 and you're adding them, say 11x plus 11y, you can factor out that 11 and it means that whole number was divisible by 11, right? This is basic level of number theory. And so then if what now? What if it wasn't divisible by 11? What if I had 11x plus 9? And that's definitely not, it's not that we don't know, it's that we specifically know it's not divisible by 11. Then this number is and this number is not, and therefore I cannot factor out 11, and therefore n is not divisible by 11. So since we want ones where this is, all we're really looking for when we boil it down, cleverly hidden, how many 5-digit multiples of 11 are there? That's the real question. And this is what the item writers, the people who write the test, they're trying to do. They like to hide the simple concept in a certain way so that you can discover it. It's kind of like an Easter egg or something like that. They've hidden it. They take joy in letting you discover the plan that they had for you to find what they were seeking for you to find, if that makes sense. So, since all we're looking for is the 5-digit multiples of n, let's get started on that process. I don't need this anymore. Let's start with I don't need that anymore either. Let's just erase all of this. We're looking for 5-digit multiples of n, right? So, what's the smallest 5-digit number? Well, it's 10,000. What's the largest? It's 99,999. And one thing you can do is you could say, I'm just going to take this number here and divide it by 11, and I'm going to round that result down. What is this? This is called the floor function. It means we're going to round down the result no matter how close it is to the next integer, we're going to round it down. In other words, we don't care about the remainder of this number. We only want full, complete numbers that were in fact divisible by 11. Now this is not just the 5-digit ones though. It's every number up until this point. So we're going to have to get rid of all of the ones that we don't want, which would be if I go down to these ones and I divide it by 11, those are the ones that are 4 digits and below. These are 5 digits and below. If I take all the 5-digit multiples of 11 and below and subtract the ones that are 4 digits and below, all that's left is the 5-digit multiples of 11. Now, you might get started, you might just be like, I'm just going to do this. I'm just going to do 11. Well, we've done division, 3rd grade, right? 4th grade, something like that. And we're just going to do this. Yeah, you can if you want. It's not that bad. But I try to find a better route. Just always try to clean it up. Always try to find a faster way if you can. We noticed that 9999 isn't that divisible by 11 as is. In fact, what if I took 9999 with a 0? Because that's really close to that. It's only 9 below it. And I know 11 goes into this number. If you know your divisibility rules, then you know why. So then I'm going to think of just this part as, well, 9999 times 10, and this would be 99 times 100 plus 1. 9900 plus 99 is that number. So then I'm going to have 99 times 101, which is 11 times 9 times 101 times 10. So if I want to know how many multiples of 11 or how many times 11 goes into this number, it's really this result here, which is 909 with a 0. Don't ever multiply by 10 and think times 10. Just think with a 0. That's the faster way to process that. So you're going to get 9,090 multiples of 11 that are 5 digits and below. Similarly, over here, it's just not times 10. So you're going to end up subtracting 909. And when you do that, you've got 9,090 minus 909. You're going to get, I don't know how to think about that. Maybe pull out the 909 and you'll have times 10 minus 1, like this. And then that'll be times 9, and you'll have 9 times 900 plus 9. I don't know. I try to just do things in interesting ways. You'll see some surprising connections, perhaps. This is 8100 plus 81. Now, all of this maybe was a little bit too cute. Maybe you could just do it straight up like this in a similar amount of time. But you should always, again, be trying to practice finding quicker ways to do things. So the answer is going to be 8181, but we got to be careful. Why? Because the test makers like to put other answers really close by, and if you're thinking, for instance, that it's b minus a plus 1 or b minus a minus 1, then you might get it wrong instead of versus b minus a. This is the one when you want a to be inclusive. Okay? Inclusive, meaning I want like 4 to 7, including the 4 and the 7. That's just an example. It's not part of a problem. Okay? So you would do 7 minus 4 plus 1. There's 4 numbers there. 4, 5, 6, 7. If I wanted exclusive, I don't want either of the endpoints, it would be 7 minus 4 minus 1. In our case, we don't want either of those. We just simply want b minus a. I want to get rid of all of these and then keep what's left. The answer really is 8181. I hope you enjoyed it. It's good to be back. And I don't know how often I'll film, as I mentioned earlier in the announcements. I've got a really busy summer, but I'm going to film whenever I have the chance. I hope you guys have a good one.